Hello guys, welcome back. In our previous video, we managed to create argument processor function which was able to interact with the CLI to get our responses, and then we move on to creating the IP processor, validators, and then performing OS fingerprinting and the manufacturer for those devices that were active on the network, or those devices that we could talk to or we could reach to. Alright, so in this section, we want to now perform the port scanning, but we should remember that we've not found a way, or we've not added a method for us to be able to talk or pass the ports that we want to scan. Alright, so let's quickly do that. So what we want to happen is, if a user enters a command on the command line or in the terminal and then passes this flag or option and say 90, I want to scan port 21, port 22, port 80, you'll be able to receive that. Okay, and there are instances that they might want to not list them, but they just want to scan a whole range of ports, maybe port 1 to port 1024, the first 1024 known port. So we want the user to pass the PR, or the long version will be port range, and then say from 1 to 1024. That's what we want the user to be able to do. So we are going to allow the user to do that over here. So the parser.add argument, and then we bring up the flag, the short version for the port, and then the long version. The number of arguments will be similar to the previously. Yes, this means that at least we need one. Okay, at least we need one port. Okay, and then this will not be compulsory, it's optional. So the type should be int. We want integers, and then by default, if the user does not pass anything, we want the default to be none. Right, so let's pass a help message that states that the flag P is the port to be scanned. Okay, the port to be scanned. Okay, so let's copy this and just make some slight changes for the port range. So for the port range, the short version will be PR, the long version will be port range, and for that we want only two, because we want the beginning. Let's say we want only 1, 2. That's the beginning of the range and the end of the range. That's all that we want. And we want them to be int, and we don't need a default. I don't know, maybe we should make the default an empty list. Yes, an empty list. Okay, so the port range, similarly the port range to be scanned. Okay, we will come back to it and then talk about how you'll be able to add the option for the user to pass how many threads he wants to use in the multi-threading, so that it speed up the program based on the processing power of their machines. All right, so let's now create validators for this course. Okay, so before we continue, this is what we want to do. So if everything will be here, so we will have self.ax, that's arguments dot port, and it will access the value, the list over here. Dot port range will access the values over here. Okay, so what we want to say is that if self.ax dot port range, that means if the user enters something, so if they don't pass anything to the port range, the default will be empty and this condition will not be satisfied. Okay, so if that's the case, then indeed please let it be so. We want you to sort it. The reason why we are sorting it is, what if the user enters it in reverse, or that's it, 1024 to 1. Either way, we want to be able to sort it in. Scan the whole port range. Okay, so we want to get started. And that if indeed the user also entered something for the port, if he doesn't enter anything, it will be none, so we don't have this condition will not be satisfied. Okay, and mind you, this will be a list. Even if the user enters one value, it will be a list, and we just want to make sure those lists are sorted in order. This doesn't affect the program in any way. It just helps us to just make things clean. That's all. So let's create a function to validate the port. Okay, let's call it port validator. hate it that I have to enter this long thing every time. So, okay. So if indeed there is a port, if indeed the user passes an argument port, we want to be able to do the following. Let's create a port bool. It's just a list away for some condition to be satisfied. So we want the port number obviously has to be greater than 0. Okay, it has to be greater than 0, and it has to be less than 65,536. That is the range of ports for I in ports. Okay, so assuming the user passes, let's do that over here. So we have the ports, and then assume the user passes 80, and then passes 22, 21, and let's say a previous number, which is not a valid port, obviously. Okay, a port, you want this, and then let's continue. We will debug this code so you get to see what's going on. And then we are saying that if we want every port to be valid, if they are not valid, even if one is not valid, please exit the program. We will not scan any invalid ports, neither will we omit it. We want the user to be very explicit. Garbage in, garbage out. That's what he said. This is what you're getting. Okay, so even if this one of them is false, this condition will be satisfied. Okay, so not false, like not false is true. All right, so we want to exit and then tell the user check the entered ports, please. Check the entered ports, and then probably show you the port, tell you that valid port number should be between 1 and 65,536. Okay, 65,536. That's okay. So that is what we want. Format code. Okay, so let's put a breakpoint over here. Let's put a breakpoint over here, and then port validator. So let's call port validator in our initialization. So say it must be initialized before anything else. So cell dot port validator. All right, so let's take it up for a spin. Okay. This is one reason why I don't like using Scapy. All right, so we can see over here. Let's open the debug console. This condition has been satisfied, so one of them is not true. So we can print p bold here, and we can see that this is true, this is true, this is true, and this one was false. So the condition, which is the last one, so the condition was satisfied. So let's change this. Let's make it 100 and see. Let's restart it and see what happens. Okay, so it was satisfied. So it was satisfied. Each of them was true, so we didn't even get to this breakpoint to verify it. Okay. People, let's see the variables will show you. Okay, so people was true, so we didn't even get. I have tried as much as possible to make sure this is very quiet and not showing numbers. I will have to check later on how to make sure it doesn't pop up in my meter. Alright, so guys, that is that for. Let's stop it. So you can see that now we can check, we can validate the port number. Let's it will be very annoying to just repeat the whole thing for port 22. So what do I do? What do I do? What do I do? Okay, so let's allow it to pass something called P to it. No, let's call it ports to it, and then clean this whole thing up. Clean this whole thing up, and then during our call, because this is the very same thing that we repeat for port range. So let's say ports. Let me call it name entered. So check the entered either port or port range. Okay. Okay, so let's, why can't I scroll up? What's going on? Okay, so at this section we will say cell.args.port. Sorry guys for the noise in the background. Okay, this is port range. Cell.args.port range. Stop it, clear this. It's too clustered over here. Let me give a breakpoint here. Okay, so at this point we are scanning the port and these are the entered ports. Okay, so please continue. And in the next step we are scanning the port range which is empty. So this condition will not be satisfied and it turns back ended. That is that for the ports. So I think we are done validating the ports. Alright, so now we need to now implement the port scanning. We need to now implement the port scanning. We are going to have a function in between here for port scanning. We are going to call it def port scanner. Okay, def port scanner. So let's create our packet that we were going to send to scan the ports. Okay, so that will be IP, and then we set the destination. The destination will be cell.target. Now let's go talk about cell.target. Cell.target we know is a generator, and that's not what we want to pass to this function. So I want to make it a list instead. R4. Okay, so that will be a list in there. Okay, so cell.target. Of course, you want to scan the whole. Oh, did you want to scan the whole? No. Sorry, there's no need for me to have done this. We just want it to be the generator as it is. Oh, I'm confused, guys. Okay, let's leave this to be. But what we need to, the ports that we need to scan is rather the active IPs. And then if you check the active IPs, I don't think, yes, this is rather the, this rather returned a dictionary. Perfect, 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 perfect. It rather returned a dictionary, so the keys will be the IPs that we need. That is perfect. That is perfect. That is perfect. Okay, so that's the IPs that we, this is what we need to check. So let's say um, let's have a local variable called active IP here and then call so dot active IPs dot keys, because the variable that it returns. Let us double check it again, guys, to make sure that we don't make any mistake with this. So we can tell what if now the question is what if there are no active IP address? Then it's going to return nothing, right? It is not going to return any. It is not going to return anything. So let's, if there is no active IP, then there's no point in continuing this program. So let's say if response, or should I call it response? If active IP, if not active IP, that means if it is empty, then sys.exit and print out something nice saying uh, sorry, there are no device none of the device could be reached. I don't even know what to. Okay, so if there's nothing, then there's no point continuing the program. If there's no active, or if no device could be read, then what's the point of even scanning any ports? So we are sure you always get something. And this is rather a list. A list, and then we are appending this to it. That is so not healthy. This method, let's make it a dictionary. Copy this. A dictionary that we pass the IP as key, and then oh, we pass this dictionary to it. So the keys will be the IP address. Okay, so when we come back to our port scanner, if we get the keys, we have all the active IPs, and we will have to enumerate through them. So we say for IP in active IP, we will create a packet of IP with a destination. Wow, sorry guys for the noise in the back. So we'll create a packet with the IP. We will need our TCP protocol, and then we are going to use only scan in this. It is very easy to use ArcScan and even XMAScan. So, and then the ports that we are going to scan will be the whole ports, which will be self.apps.port. Right, now that reminds me of something. Okay, so let us think of something here. What if we have that the user has entered a port, assuming the user wanted to check this very particular port and also this port range at the same time? What do we do? Okay, and maybe you want to also check ports, maybe from port 2000 to maybe port 5000. The user wants to check this individual ports and then this port range at the very same time. So what do we do? Let's go back to our port validator, and where's our port validator? So you remember we passed them separately. Now that seems to be a problem because okay, let's do this. Alright guys, so let me stop this. Okay, so previously I wanted us to do some analysis. I paused the video and I explained to you guys that what if the user wants to scan this ports but scan this port range too at the same time. So we wanted to deal with that, and I mainly want to do that because I want to put all the port and port range into one list and then scan everything all together. Okay, so I zip the input, this input. These values are just to help us print some nice things out. Okay, you just love the printout. So I zip them together as one. Okay, and I'm looping through them. Now I call it data. So for ports, comma name in data, I want to do the following. All right. So at the end of this loop, if it doesn't happen that we check out, that means that all the ports and port ranges are valid, right? And this is what I want us to do. I want us to combine the ports and the port range together as one. The port and the port range, the whole values together as one. Okay, so they are both different lists, and we need to do something to get them to be together as one. And we are going to use what they call, I've forgotten the name of that function, but let me show you guys what I'm talking about. Alright, so let me show you guys what I'm talking about. So assuming we have this function. Okay, so let's clear this place and then, okay, so assuming we have this function from I travel, this function will help us combine all of any I travel that you pass to it into one. So A, B, C, D, E, F will be combined into this form. Okay, yield element. So assuming you have this function, and then we call, let's say A, we call from I travel, and we pass the, let's say we have port 22, 21, 30. Okay, and then we have another port range, which I'll deal with it later. Let's say 1 to, or let's say 80 to 120. Okay, and then from my travel takes position. Takes one position argument. Okay, it takes one position argument. Yes, it takes one position argument, of course. All right, so before let's say that we have ports equal 22, 21, 23, 25, 100, and then we have port range equal to 90, 90 to 140, 90 to 140. So what we want to do is let's call a which is equal to from I travel, and then pass a list of ports, comma PR. So it's like a list containing list. Okay, list of list, and then you run it. Oh man, what am I? Look at all this. Yes, ports. Okay, so this will be a generator function. So we can say that I don't know why I'm making this mistake. From I in A, print I, and then let's let in space. Okay, we don't want to print a whole list. I don't know. Sorry guys, I don't know. Maybe I should for I in A. Okay, so now you can see that we have ports being this and then PR being this. So you can see it has combined them together. Okay, but mind you, that PR is a range, so we don't want it to be like this. Okay, so let's turn PR. Let's make PR will be equal to list of range at the first point of PR and then the next point. So we have PR, of course we have PR to be this, the whole range. Okay, and then so now let's call A again, and now let's say for okay, all right, and then now we have the whole range. We have 90 here. Our PR started from 90, and our ports also included 90. Where is it? Okay, our port included 100. Our PR started from 100, so from 90, so I'm expecting that 91, 92, 93 has repeated itself. It's not repeated. Okay, so we have 100 here, and then we also have another 100 here. It is repeating, so that doesn't make sense. So we will now apply set to whatever that we have, and then it will remove the duplicates. So that's what we want to do. Okay, so let's go back. We will let's create a folder called auxiliary. I don't know how many of such functions we will need. Let me call it helpers. Helpers. A folder called helpers, and then How do I even call the function? Let's see, nice functions. Bad maybe nice functions dot py. Okay, and then I that's not it. Let me not for myself. Okay, so you'll see from helpers dot nice functions import from iTravel. Okay, you want to import that, and then when you import that, when you come to the port validator, uh, what we want to return is a list that we apply set on. Let me yes, a list, and then we apply set on that list, and I will call from iTravel, which the results will be a generator. So we will say I for I in the generator, which will be from iTravel, and then we are going to pass a list of the we want to pass a list of the ports. So let me create an empty list here. And each time this condition is not satisfied, before it goes back, I want to do p dot append ports. Okay, so and then I'll pass p to this. Alright, so it will go and combine them, the whole range. I have to be careful. Now this is becoming more cumbersome than I expected. If name is equal to port range, if name is equal to port range, then I want to uh, make ports to be equal to the stuff range of port 0, port. The best method is to debug it so that maybe you see the logic, or I might even confirm some fallacies in my logic. So when we look over here, we will realize that when we step over at this point, our ports are this, okay, and our name is this, so we don't need this. So now P will become list of lists which contains the ports, and then let's go through it. And this time around, our name is port range, and this is the range. So our people all are true, so this condition will not be satisfied. And then now, since the ports and the port range, the name is the same, we expect to okay. So now you can see the port is now the list of all of them, the list of all of them, the list of all of them. Perfecto. I think the only problem is that I will have to increase the range +1 so that it includes the last value, because why is this thing please move? The range was 5,000, so we need the last value too. Let's go to the debug console and print ports, print the last value. You can see it's 4,999, but we need the last value too. That's what it is entered. So alright guys, and if that happens, +1. Now let's start over again, and this time around I'm going to set okay, so continue, and okay, so we are going to step into okay, so it should return something. It returned none, really. That was a mistake on our part. let's call this self.port will be equal to this. So let's run it and then remove these breakpoints. Set the breakpoints here instead, and then yield element. So that was an error. So let's restart. Okay, so let's see what self.port is. Self.port. Okay, so you can see self.port is now 20, 22, 80, 100, the whole ports, and then the whole port range. So now we have the whole, you understand, we have the whole ports, be it port or port range, whatever it is, we have all of them together. Nice and simple. We are not done. I don't know, actually, the more we do it, the more I remember a couple of things that we have to include in the in a program. Okay, so now there is a question before we even return. There's a question that comes to mind. It's very dangerous. We are returning this, but you now see. Okay, so what if there was no ports? The user did not enter any ports. The user did not enter any port range. Okay, the user did not enter any of them. So instead of, let me shift it. Oh, shit. Why? You should just, okay. So if port, so if assuming the user did not enter any ports, let's run it for you to see what I'm talking about. Assume, let's cut the whole of this from there, and then let's see, let's remove these breakpoints, and then let's just come to return this. Let's start over. So you can see P is empty. It's empty mainly because the user did not pass any port, nor did he or she pass any port range. Okay, so we want to make sure that if that's the case, if the user not enter anything, then scan the whole 1024 ports. Okay, that's what we want to do. So let's stop this and then check how are we going to do that. So if this condition is not satisfied, so P is empty throughout the whole looping, then what we are going to do is if P, if not P, so if it is empty, then return a list of range 1 to 1025. This will ensure, oh sorry, this will ensure we get that 1 to 1024, you know, the minus 1. So yeah, if that's not the case, you come here. I don't know, this doesn't feel too Pythonic, but yeah, it will get it all done. I believe it will get it all done. So if it is not empty, it will not come here. Then it will skip and then run this, and then let's test it and see. So okay, you can see it is already. Let me stop it. It didn't get to this point where the breakpoint is. It is already doing its thing over here. Okay, so that is it, guys. And if I pass something to it, it should get to the breakpoint. It should get to the breakpoint. Okay, so you can see it is up to where the breakpoint is, and then it will run and everything will be beautiful. Let's assuming we have only the ports, we passed only the ports, not the port range. What happens? It still gets to that point, and then so let's check self.ports. Let's check self.ports. Okay, perfect. It works. Whatever the case may be, our program is very resilient to, wow. Now we go sidetracked. Let's go back to the post scanner. Okay, so now we've managed to get all the ports into self.port as a variable. So now the port that we are going to scan is the whole port at a go. We want to scan the whole ports at a go. Okay, so for each IP address in the active IPs, we want to scan the whole ports of the port. Sorry. All right. Okay, that is nice and beautiful. Okay, so now let's continue this. We have our packet. We've created our packet. We now need to send it out and then wait for response. So answer and then on answer, and you will see SR send and receive the packet. We won't pass any timeout, neither verbose option. Let's test it out and see what happens. Right. But before that, we can check for the packets with open ports. We can check for packets with open ports by the answer that we get. Let's filter it. We filter it with this function lambda s comma r. If you have TCP layer in R, and that it happens that the TCP layer of R has a flag equal to SD. This means that when we send, remember that this is a send scan. When we send the send request, we got an acknowledgement from whatever ports or server or whatever. We got an acknowledgement and then we terminated it. We don't need to complete the three-way handshake, all right? So we terminated it. So this will give us, this will filter out the right, and we can for starters, let's print the the summary. Let's print the summary. Leave a breakpoint here so that okay, so let's print the summary out. Or we can better still, okay, let's print the individual ports out instead of the whole summary. So let's say let's print, okay, so and then for scanning for a particular IP, and then we also print this out. Okay, and then we go like for mm, okay, so let's say for s comma r in packets open ports. Okay, let's print out that you have class TCP um, I've forgotten the exact. Let me check it out. Okay, so open at S. Okay, is opened. Okay, and that should do it. So we have a breakpoint here in case anything what is going on. Alright, so let's take it for a spin and see. Oh, let's remove the breakpoints. Okay, so we are having, okay, these are the, it seems that because I'm using it on my virtual machine, it is always printing out the very same MAC address for my Wi-Fi card, and it's telling me it's Realtek, and Aptech 2 is also reported. It's telling me the various operating systems on it. I'll have to check how to suppress warnings in Scapy. Or maybe Python in general. Oh my, we have not called our postcard in anywhere in the code, so we didn't get any results. Sorry guys. Let's let's call postcard and then so, postcard. So I'm going to pause it and wait for it to finish and then continue. So guys, the scan is done. We completed the scan as usual. I determined the devices that could be reached, and it found this port to be opened on this IP address. Nothing was found here. We will have to print something to make it look nice. And it found 21, 22, 80, 111, and then 139 to be opened, right? So we will now need to create our port banner so that we grab the banners for each port and also include them in our printout nicely. And then our last step will be to check for common vulnerability and exploits. And then finally, we will wrap it all up with multi-threading to ensure that our program runs at a very fast speed and finishes within a short time. Even though for some situations and for some um, implementations put in place with respect to either the risk or the number of packets being sent to a particular target and all those things, I believe that if firewall or some intrusion detection systems detect that you are sending too many packets, uh, maybe they could flag or ban that particular IP or something. So we are just focusing on creating it, making sure it works. For efficiency's sake, we will include the multi-threading, and then later on we will consider those possibilities and what flags we should allow the user to pass to the program to stop those things. And yeah, and okay, so that is it. See you in the next video. Bye. Stay safe.